Hello guys, this is your video for lesson 4.3. So on this lab, we're going to be changing the surface area. So the first lab, we went and we changed our surface type. The second lab, we changed the load. And this time we're changing the surface area. So on all of these, we've been looking at how friction is affected, or how the force of friction increases or decreases based on what we change. So again, this time we're looking at surface area. So what you need to do to begin with is, number one, look at the picture at the bottom of the screen there. That is showing how we're going to set the lab up and how the lab is run. So you set the block up at different positions and you drag it across your intended surface and you take the data. And we're flipping the block around. So I'm going to slide the video down and play a video, and it's going to demonstrate what we did to take data for this lab. So notice we took our first set of data based on the wide setup, which was how it first was. So this is going to be narrow 1 on the table I'll show you in a second. So notice this one's a little longer than it was the other way. And then we're going to take the rubber band off, flip it over, and we're going to test it on the other side. So we're looking at how changing the surface area that's in contact with the surface will change the force of friction. All right, so yes, you couldn't see the scale on that, but I'm going to present you with data, and we're going to talk about the data here in just a moment. So I'm going to pause the video, and you'll see it pop up in just a moment. All right, so here is your data table. You should have this in your science notebook, and if you don't, you need to pause because you're missing a whole lot in your science notebook at this point. You need to get that fixed. So if you're still here, you are good to go, and you're ready to take some data. So I'm going to go over the data with you, and we're going to talk about it as we go. So we're going to test one surface type each as groups in class. However, I'm just presenting you with the data, and we're just going to talk about it here. So for the wide setup, that is this right here, I'm going to give you the numbers for all of the trials for wide, narrow 1, and narrow 2. And then I'm going to go back and we're going to talk about some of them. All right. So on wide for the tabletop, we had 0.45. And that is newtons. Make sure you get your units. Coarse sandpaper was 1.7 newtons. Fine sandpaper was 1.9 newtons. Wax paper was 0.4 newtons. And paper towels were 0.7 newtons. All right, narrow 1, this is the second row where we're putting data in. The tabletop had 0.5 newtons. Coarse sandpaper had 1.8 newtons. Fine sandpaper had 2 newtons. Wax paper had 0.4 newtons. And paper towels had 0.75 newtons. Narrow 2 started with 0.55 newtons. Coarse sandpaper, 1.7 newtons. Fine sandpaper, 1.9 newtons. Wax paper, 1.5 newtons. And the last one, paper towels, 0.7 newtons. Okay, so let's talk about the data real quick. So for the wide, on the different surfaces, we got the following values. So wide looks like this. So if you look here, I'll zoom down and you see that's how the wide was done. So here is how everything came out. So with the wide surface area, or just the bottom of the block in contact, that was the force of friction on each of the surfaces. So take a moment, pause the video, look at each of the surfaces and the values for wide. All right. So now this was narrow 1, like you see here. Gotta pause the video. So what you see there is narrow 1. We have it turned on its side. You have more of the wood in contact with the surface now because it's the longer section. So again, notice our values here. So pause the videos and look how our values changed based on putting more wood in contact with the surface. All right, narrow 2, notice what we did here. We took the rubber band off, we flipped the block upside down, and we put the rubber band back on it. And we took the measurements again on the other side of the block. So, again, notice how it changed. It wasn't the same as narrow 1 because it is a different side of the block. All right, so that pretty well wraps up the lab. So we're gonna go through and answer some questions in your science notebook at this point. So in your science notebook, the first thing you have is you have a prediction to make. So what you're gonna do in your science notebook, read along with me here and we'll talk about it. Look at your block. And again, the block is what you've seen the blocks at this point. You can turn the block on its wide side and pull it, or stand it up on its narrow side and pull it. When the block is on its wide side, the area in contact with the surface is greater than on the narrow side. You pulled the block across surfaces on its wide side in the previous trials. So, predict what will happen to the force of friction when you pull it on the narrow side of each surface. Write your prediction in your science notebook. All right, so pause the video if you need more time to do this, otherwise we're gonna go on. Number 2 was the data table that we just went over, so that should be good to go. All right, so the next item's number 5, and we'll pick up on the next page. Number 3 here just tells you to go across and take your data. So I'll see you again in a moment. All right, so number 5, record your answer to the following questions. How did your prediction compare with your results? So look at the prediction you wrote and then look at the data table and see how your answer fared. Again, just answer how you were right or if you were wrong. Pause the video if you need more time. So 6, think about the variables. Which variables did we keep constant? Record your answer. So this is a scientific method question. So the independent variable for this was the surface area. We changed the way the block was oriented on the surface, or we changed its position so that it would sit on a different side. What variables did we keep constant in this experiment? Pause the video, answer the question. All right, reflection questions. So these are off to the left, right here, and we've got one change. So answer these questions in your notebook under the reflecting on what you've done. All right, 1A. I changed that one, so you're going to answer the one in white here. Identify the independent variable for lessons 4.1, 4.2, and 4.3. What did we change in each experiment? So you're going to do 4.1, what was the independent variable? 4.2, what was the independent variable? And 4.3, what was the independent variable? Make sure you number those so you don't get them lost. Pause the video, answer the question. B, in this lesson, you measured sliding friction. Why does the force on the spring scale measure the force of friction while the block moves at steady speed? So why does the force on the spring scale measure friction when we're pulling the block at a steady speed? All right, pause the video, answer the question. C, suppose you used ice as a surface for the block to slide on. What results would we get for the lab? So it wants 3 answers here. It wants you to talk 1, what happens if we tested surface area on ice? What would happen if we tested the weight on ice? And what would we get if we tested the surface area? So just to summarize that, 4.1 was our surface type, is what we tested. 4.2, we tested how weight affected the force of friction. 4.3, we tested surface area. So take a moment, pause the video, and how you think if we had ice as a surface to test on, how each of these would have been affected, or how the force of friction would have changed if we were on ice. All right, so once you answer that, the final thing you have left to do are your reading selections. So make sure you read those, take your notes in your notebook, and if you have questions or you need to check something, please reach out to me. Otherwise, you guys have a good day. I'll see you in the next video or in class.